You've been told that alcohol is a depressant, and that's technically true, but it's the most misleading half-truth in neuroscience. Because in the first minutes after your first drink, alcohol doesn't depress your brain. It does something far more specific and far stranger. It silences the part of your brain that's been keeping you polite. The moment alcohol enters your bloodstream, it's already crossing the blood-brain barrier. That's not a figure of speech. Within about 5 minutes of your first drink, ethanol molecules are physically present in your brain tissue, binding to receptors, altering the electrical behavior of neurons. There is no warming up period. There is no getting into your system. You are already in it. And here's where it gets interesting. The first system alcohol hits isn't the one that makes you sleepy. It's the one that makes you anxious. Your prefrontal cortex, the region that monitors your own behavior, predicts consequences, and generates the quiet, constant voice of social inhibition, begins to go quiet. GABA receptors open wider. Glutamate receptors, which drive excitation, start to close. The result is a selective dimming, not of everything, but of the watchman. You don't feel depressed, you feel free. This is what people mean when they say alcohol takes the edge off. They're describing the pharmacological silencing of the brain's self-monitoring systems. The edge is your judgment. The alcohol doesn't take it. It mutes it temporarily, while the reward circuits underneath continue to run warm. Your dopamine system is largely untouched at this stage. In fact, it's slightly elevated. Alcohol nudges the nucleus accumbens, the brain's reward hub, into releasing a modest pulse of dopamine, the same neurotransmitter associated with food, sex, and social bond. This is why the first drink can feel like relief. Biologically, it is. But think about it this way. The brain doesn't experience this as freedom. It experiences it as a system going offline. And the moment a monitoring system goes offline, the brain starts compensating. By your second drink, that compensation has already begun. Your blood alcohol concentration is climbing towards 0.04 to 0.06%, a range where most people begin to feel what the research calls euphoric disinhibition. Conversation flows more easily. Self-consciousness retreats. The internal editor that normally reviews every sentence before you speak it has stepped away from the desk. But behind that feeling, your brain has started quietly upregulating its excitatory systems, producing more glutamate receptors, making them more sensitive, trying to restore the balance that alcohol is disrupting. You don't feel this. You feel good. The brain's counter-response is invisible at this stage, running beneath the surface of your awareness. But here's the thing. It's already happening, and it is the seed of every bad feeling that comes later. Around 30 minutes in, your cerebellum is now involved. Coordination and balance are handled here, and it's exquisitely sensitive to ethanol. This is why your handwriting changes before your speech does. The cerebellum is upstream of the motor cortex. It plans movement before the movement happens, and alcohol degrades that planning. You're not less coordinated because your muscles are weaker. You're less coordinated because the timing signals are arriving late and distorted. A sober cerebellum doesn't just execute movement. It predicts the sensory consequences of movement and corrects in real time. Take that predictive system offline, and the body becomes slightly behind itself in everything it does. Simultaneously, your amygdala, the brain's threat detection center, has grown quieter. Under normal conditions, the amygdala runs a constant low-level scan for social danger, judgment, rejection, embarrassment. Alcohol damps this signal. What you experience as social ease, warmth, and loosened inhibition is partly the amygdala standing down from its post. The catch is that the amygdala doesn't just detect threat, it also tracks social nuance. When it goes quiet, so does your read of the room. At 0.08% blood alcohol, roughly 3 to 4 drinks in 2 hours for an average-sized adult, your hippocampus begins to lose its ability to consolidate new memories. This doesn't mean you're unconscious. It means the mechanism that transfers experience from short-term to long-term storage is failing. You are present, responsive, apparently functional, but the recording has stopped. What you experience in this window may not be accessible to you tomorrow, not because it was overwhelming, but because it was never stored. The blackout, when it comes, isn't a gap in consciousness. It's a gap in encoding. From the inside, the evening feels continuous. From the outside, and from the next morning, entire chapters are missing. And here's where it gets interesting at a deeper level. Throughout this entire process, your body is treating alcohol as a toxin, Because it is. Your liver has been metabolizing ethanol since the first drink, converting it into acetaldehyde, a compound significantly more toxic than ethanol itself, before breaking that down into acetate, which the body can eventually use as fuel. The liver can process roughly 1 standard drink per hour. When you drink faster than that, acetaldehyde accumulates, flushing, racing pulse, nausea. These aren't signs of weakness. They're signs that your detox system has been outpaced. In people who carry a particular genetic variant of the enzyme that clears acetaldehyde, this toxic intermediate builds up faster and more severely. That's the mechanism behind the flush response common in some East Asian populations. It's not a different relationship with alcohol. It's a different rate of poison clearance. Meanwhile, alcohol is suppressing vasopressin, the hormone that signals your kidneys to retain water. This is the mechanism behind the dehydration that turns the next morning brutal. For every drink you consume, you urinate more fluid than the drink contained. The headache, the dry mouth, the hypersensitivity to light and sound. These are, in significant part, the result of your brain and surrounding tissue losing volume and pulling slightly away from the membranes that surround them. That tension on the meninges, the protective sheaths around the brain, is one of the primary drivers of the throbbing quality of an alcohol headache. It is, in the most literal sense, your brain shrinking away from its own walls. But the truly consequential chemistry is happening in your sleep, or more precisely, in what's being stolen from it. Alcohol is sedating, which is why so many people use it to fall asleep. But sedation is not sleep. Within the first 2 hours of unconsciousness, alcohol suppresses REM sleep, the stage in which the brain processes emotion, consolidates memory, and performs a kind of nightly psychological maintenance. During REM, the brain replays emotionally significant experiences, strips away the emotional charge, and integrates new information with older memory structures. A night of drinking is, neurologically, a night of reduced repair. The grogginess you feel the next day isn't just the hangover. It's also the accumulated cognitive debt of a brain that was sedated when it should have been working. In people who drink heavily and regularly, this REM debt compounds across weeks and months, contributing to the emotional blunting and cognitive fog that chronic drinkers often describe and frequently attribute to other causes. You've probably noticed this yourself. The way the day after drinking can carry a particular quality of emotional flatness, a low-grade fragility that isn't quite sadness and isn't quite anxiety but feels like both. There's a name for this in the research literature, hangxiety, and it has a mechanism. The GABA receptors that alcohol pried open have now been down-regulated by your brain's compensatory response. The glutamate receptors have been upregulated. Take the alcohol away, and the result is a nervous system running hotter than baseline, more reactive, less resilient, for anywhere from 12 to 48 hours after your last drink, depending on how much you consume. Your threat detection systems, briefly quieted by alcohol the night before, are now overshooting. The amygdala is back at its post and running on high. This is not a metaphor for regret. It is the literal neurochemical rebound of a system that was suppressed and is now overcorrect. This is not a moral observation. It is a circuit. Your brain was knocked out of equilibrium, and it's correct. The fact that this correction feels like anxiety isn't ironic. It is the mechanism of anxiety, briefly but genuinely, running through a brain that is doing exactly what it was designed to do. What does this mean for you? It depends almost entirely on frequency. A single drink triggers a cascade that resolves cleanly within a day or two. 2 or 3 drinks push the compensatory response deeper, and the rebound takes longer. Regular drinking begins to shift the brain's baseline. The glutamate and GABA systems gradually recalibrate around the presence of alcohol so that the unmedicated state starts to feel like the abnormal one. Chronic heavy drinking goes further still, initiating structural changes. A gradual loss of gray matter density in the prefrontal cortex, reduced hippocampal volume, and a dopamine system that over time begins to respond less to everyday pleasure and more insistently to alcohol specific. The things that used to feel rewarding feel flat. The drink that used to be optional starts to feel necessary. This isn't weakness of character, it's synaptic economics. The brain allocates sensitivity where the signal is loudest, and for a long time, alcohol has been the loudest signal in the room. What's remarkable about all of this is not that alcohol is dangerous. Most people understand that at some level, but that the effects are so mechanically precise. Every stage has a named receptor, a measured blood concentration, a documented physiological pathway. The feeling of loosening up at a party is a GABA event. The gap in your memory is a hippocampal encoding failure. The anxiety the next morning is glutamate rebound. None of it is vague. None of it is mysterious. It is chemistry behaving exactly as chemistry does. The science here isn't a cautionary tale, it's a mechanism. And mechanisms don't judge you, they just run. So here's what I want to know. Did any part of this change how you think about alcohol? Not morally, but mechanically? Let me know in the comments. And if you found this useful, the like button is the only way the algorithm knows this kind of content is worth making.